our math foundation. And for showing the results from the design, we went through the display menu, show slab design, and we had the option to choose a uniform meshing at the top and bottom and have some additives to that existing meshing. So we chose number 18 at the top and bottom, and we can say, okay, number 25 as the extras. So it shows you that okay, you need some extra along the columns, the internal columns. So this is a good strategy to reinforcement arrangement for your mat foundation or strip foundation or even pad foundation. And but to elaborate more with this concept, we can go to the detailing. In terms of design, we have detailing menu there just to more elaborate with the design results. First of all, I go through this one, mat preferences. And here I can say that default is this one. I change this to this rebar detailed option to use okay, you can use meshes of numbers 18, or I just chose 16. The lesser reinforcement, the more optimum you are, aren't you? So I'm using meshes of reinforcement 16 every 25 centimeter at the top and bottom. And in addition, we will use some extra rebars where required. And if I press OK, and for the detailing, you can go and start the detailing. And in the detailing, you can see that here you have surface view, plan view. I go through the plan view and the top and bottom rebars, all of the top and bottom rebars. And you can see that, what is this? This says you have meshes number 20 at each 25 centimeter. This is top, this is bottom, this is dashed line because it's underneath the, the top reinforcement. So you have a mesh like this at the top, a mesh like this at the bottom, and you can see that you, in addition to those, you have some additives like number 32 at each 1,000 millimeter here, and number 32 at each 3,000 millimeter in this area. So why it change number 16 of mine to number 20. I just close this one. Again, I go here and it's a very big. I have three tabs at the top. Sorry, the middle tab is math. So the middle tab, I need to define this one at 20 or 18 or 16. If I set it as, to the 16, so this one is the middle one, the math foundation. If I set it to 16, each 25 centimeter, and okay, that's fine. I press OK. It says that you need to repeat the detailing. That's fine. I just clear detailing and redo the detailing. Now, if you go to the surface, to the plan view and top and bottom bars, you can see now you have number 16 at each 200 millimeter, 250 millimeter. This is the top. This is the bottom. And you have these extras, number 32, at other places. So this is more optimum probably because you have two meshes and some additives. So if the additives are too less, it means that you're using too much of a reinforcement in the original meshes. So it's a compromise between the meshes and the additive reinforcements, up to you and the decision of the designer. So you have this kind of reinforcement for your design, and this is really the output of your design. If everything works well, if the flexural design is okay, the shear design and punching shear design is okay, which is apparently not. You need to take a look at the punching shear forces. That's another story. And for flexural design, it's like this. It works. So uh, I want to bring your attention to this fact that in the file menu you have the export option, and you can export everything to DWG file, which means that I don't have AutoCAD on my computer here. I cannot do this, but I assume that if you export your file into DWG file and open it through the AutoCAD, you can find all of these detailings there. There is another option to export it to CSI Detail. CSI Detail is another software, belongs to the CSI company. We don't have it now. So this is another option if you want to proceed with that in some other cases. And also you have the export option to Revit. And you know, the Revit is some sort of software that you can create a BIM model there, BIM model. So you can have inputs from everywhere, from structural engineering, from mechanical engineering, from electrical engineering, from environmental engineering, and all of the informations come together in different layers of information, and you can have a BIM model created for your project. That's the ultimate objective of any engineering project like this one. So you can have foundation export to the Revit, or superstructure from ETABS exported to the Revit, and everything gathers in the Revit. But you need to export these data whenever you're completely happy with your design, because you cannot change anything when you go to the other software like AutoCAD or Revit. So you need to be very happy with what your calculations are in this stage. And I want to introduce another amazing feature here. You can create a report, an engineering report for your design, which is basically what I'm anticipating from you for your report for the coursework. However, it's quite more complicated and I mean, not complicated, comprehensive in every aspect. If you go for show project report, um, you it encountered error. Probably I need to redo it. I just need to probably the analysis, because I changed many things. Whenever you're happy with your design and you don't want to change anything else, you need to do a final analysis, a final design, and a final detailing, and then export your report. So for the design, I just start the design, and for the detailing, I just clear these detailing and start detailing again. And here we are. If I go and create the report, um, probably I have created this before once, and now it encounters error. So probably I need to restart my computer, but I'm pretty sure it will work in your computer, and it will provide you with a very comprehensive report regarding different checks and different DCRs. I need to probably restart my computer and try it again, but I have done this today once, and you can have a complete report or you can have a summary report, and there are some other options. Just feel free to explore more and elaborate more with them. So you can export your detailings into the AutoCAD. You can create an engineering report based on your calculations, and that's very awesome to have everything incorporated in one software that provides you with all the necessary informations you need. So today, with the previous video, you learned how to do structural design, shear design, punching shear control, and soil stress control and deformation control. These are the first five controls that you need to do in your project reports. Plus, the sixth and seventh are about sliding control and overturning control, which are something that we will discuss later. For now, you can just focus on the first five control points for your project and try to figure them out, especially working on the punching shear control to see how we can solve the problem. Currently, you can see that the punching shear control doesn't work for my case with the 500 millimeter depth in the foundation. I'm in trouble for punching shear, and I need to figure out some engineering solution. And this is something that I want you to think of, and we will have a brainstorming during the lecture time on Friday about this problem. So thank you for your watching, and see you all in the coming Friday. Thank you. Have a nice rest of the day.